Third sum. Find the LCM and HCF of the following integers by applying the prime factorization method. Okay. The given numbers are 12, 15, 21. Okay. We know that the prime factors for 12 are 2 into 2 into 3, and for 15 3 into 5, and for 21 3 into 7. Okay. If you want to find HCF, first what we have to do, we have to see what is the common prime factor among the three numbers 12, 15 and 21. We can clearly see that 3 is the only common prime factor among all the three numbers. So HCF of the given numbers are 3. Now if you want to find LCM for the three numbers, what we have to do, first we have to see what are the prime factors that are involved among the three numbers. For 12 they are 2 and 3, and for 15 they are 3 and 5, and for 21 3 and 7. So 2, 3, 5, 7 are the prime factors that are involved among all the three numbers. Okay. Since LCM is equal to the product of greatest powers of all the prime factors involved among three numbers, LCM of the given numbers 12, 15, 21, which is equal to the product of 2 power 2 into 3 into 7 into 5, which is equal to 420. Okay. And HCF is equal to 3. Okay. Next problem. The given numbers are 17, 23 and 29. Okay. First step, we have to find the prime factorization for the given numbers. But here, when we saw these numbers, we can clearly say that these three numbers are said to be prime numbers. That is, they don't have any factors other than 1 and itself. Hence, for this type of numbers, the HCF is considered as 1, and the LCM of these numbers is the product of the numbers, that is 17 into 23 into 29, which is equal to 11,339. Okay, third problem. The given numbers are 8, 9 and 25. Okay, we know that the prime factorization for 8, 9 and 25 are, for 8 it is 2 power 3, and for 9 it is 3 power 2, and for 25 it is 5 power 2. Okay, here also if you want to find HCF, we want to see what are the common factors that are among the three numbers, but it is clearly seen that there is no common prime factor available for three numbers. Hence the HCF is always treated as 1 in the case where there is no common prime factor. If you want to find LCM, the LCM is defined as the product of greatest powers of all the prime factors assigned in the given numbers. Here the prime factors assigned are 2, 3 and 5. So its highest powers is 2 power 3 into 3 power 2 into 5 power 2. Hence the product of all these, which gives the LCM, that is 1800, and HCF is 1. Okay. Fourth problem. Given that the HCF of 306, 657 is equal to 9, find the LCM of 306, 657. Okay. Here, based upon the note, they have given the question. What is the note? We all know that there is a relationship between LCM, HCF and the product of two numbers. Okay. Given the HCF of 306, 657 is equal to 9. Okay. And we want to find now the product of two numbers, that is 306 into 657. Then the LCM of 306, 657 is given as LCM of 306, 657 is equal to the product of two numbers, that is 306 into 657 divided by HCF of two numbers 306, 657. This implies 306 into 657 divided by 9, which is equal to 201042 divided by 9, that is 22,338. Okay. Fifth sum. Check whether 6 power n can end with the digit 0 for any natural number n. Okay. He was asking in the question that whatever the value of n you keep in the equation 6 power n, is it ended with 0 or not? Okay. See, if 6 power n want to end with the number having the last digit 0, then it must be in the product of 2's and 5's. That is, if a number 6 power n for any values of n were to be end with a 0, then it would be divisible by 5. That is, the prime factorization of 6 power n would contain the prime 5. This is not possible because 6 power n is factorized as 2 into 3 whole power n. It does not contain any 5 term, hence the uniqueness of fundamental theorem of arithmetic guarantees that there is no other prime factors for 6 power n, so there is no natural number for n for which 6 power n ends with the digit 0. Okay, it clearly simply states that if 6 power n for any value of n it ends with 0, it must be divisible by 5. But if you find the factors for 6 power n, we are getting 2 and 3 but not 5. Hence, for any values of n, we cannot make the number that having a digit ended with 0. Okay. Sixth problem. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Okay. They are asking why these two numbers are composite numbers. If a number is said to be a composite number, if it is having an other factors other than 1 and itself. That is, if you want to find whether these two numbers are composite numbers or not, then we want to first solve these two numbers. Okay, for 17 into 11 into 13 plus 13, the total is 1014, which is a product of 2 into 3 into 13 into 13. This resembles that it is a product of prime factors of 2, 3 and 13. And now, for second expression, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5, the resultant is 5045, which is a product of two prime factors 51109. Hence, by seeing all these, we can say that these two numbers have other factors other than 1 and itself. Hence, this can be considered as a composite numbers. Okay. Next question. There is a circular path around a sports field. Sonia takes 18 minutes to dive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and they go in the same direction. After how many minutes they will meet again at the starting point? So for this type of questions, we want to find LCM for the given two numbers, that is 18 and 12. We get 36 minutes, and this 36 minutes is a required time. That is, so after 36 minutes they again meet at the starting point, right? Okay.